So what exactly is a relational database, and why do you need one? Why does your business need one? You probably heard these terms a lot of times. You might have looked in your Office 365 subscription and see this, well, okay, I know what Word is, I know what Excel. What is this A? What is this Access? And what does it do? Access is a relational database, and I want to go through this presentation. I want to show you what a relational database exactly is. I promise I'm not going to get really technical. I'm going to keep this very general in nature. First of all, who am I? Well, my name is David Britz. I'm an IT professional, a Microsoft certified database specialist. I'm going to give this talk about relational databases. I hate hard selling. This is not one of those hard sell webinars where you sit there for an hour and then, they give you all this dog and pony stuff and then they say, oh, but for only this amount of money. My mission here is to just give you information on what a database is and show you why, whenever you're dealing with information, and any business deals with information, why it's so important. So I'm going to talk about what is data. Then we're going to go into spreadsheets. You probably all have seen a spreadsheet of some kind or another. The risks of bad data. Some of these later bullet points, normalization. I understand that's a kind of a foreign word right now, but we'll get to that. Tables, relationships. And what I'm going to show you, the main gist of what I'm going to show you here is the migration, the difference between an Excel spreadsheet, let's say, and an Access database. What's the difference between the two? Excel and Access. What can one do that the other one can't? So what is data? Well, everything is data. I mean, if you have a business, you're dealing with data. Now that could be employee and customer records, sales records, inventory, accounting, bookkeeping, address books, contact lists, sales leads. Data is everywhere. If you have a business or if you don't have a business, you're dealing with data. Your monthly household budget can be represented in a database. So it's just everywhere. You're probably familiar with spreadsheets. And I want to just go through, because you hear a term a lot, data cleanup. And one of the things that I do is data cleanup. Let's suppose that this is just a kind of a piece of an address spreadsheet. And you can see there are some problems. Idaho, look how many ways Idaho is spelled. ID period or without a period. Washington could be spelled out. Here you have the zip code along with the state. In any event, this shows you what can happen. And this is a case where probably data was misentered, or it was an application that somehow allowed, it didn't check to make sure that a state was actually a state. And, garbage in, garbage out. If your data is inconsistent or it has errors, how are you going to do when you have to look, when your application has to look that data up? You got a customer calling, you can't find this customer's record because Idaho is spelled wrong. I mean, this is serious stuff. If your data is, for lack of a better word, messed up, it's going to really affect your business. You're not going to be able to find the records you need. They'll be slow. You could have angry customers even. So this is a situation where it really needs to be fixed. It really needs to be cleaned up. And even more so, we need to prevent it from happening again. I want to show you one more table, and this is going to kind of launch the rest of the talk. This is what a typical sales spreadsheet table might look like. Not all the data is present here. Some of you might be saying, well, there's no telephone number, there's no email address. That's true. And, I truncated this a little bit just to kind of fit it on the screen. So yeah, there is some information missing from here. But do you see problems with the organization of the data? Is there a problem just with the structure of the table and how the information that is there is set up? But I want you to pause the video for just a moment and see if you can identify any problems, structural problems with the way this is set up. Okay, well let's take a look at the next slide, and we'll kind of go into just a few of the problems we have here. First of all, notice that the names are being stored twice, or actually not, well, at least twice. Some of them are stored at least twice. You see a lot of names that are repeated. The names are repeated, the address is repeated, the city and the state. It's a lot of redundant data. Why do I mean, if you have a table of 5,000 orders, that's probably a pretty small business. Let's say maybe 100,000 orders, and you have one customer. There's a regular customer. They're in there 5,000 times. Do you really need to store their address, their city, their state 500 times? The only things that differ. Let's take Luke's records here. I mean, they differ in what he ordered. Although, well, no, actually, no, these are all the same order. These are different order dates. So yeah, the order date is the same. That's another redundancy. The product names are different. Suppose that Cindy and Charles Brown, you notice that they have the same address. Let's assume they're a married couple. What if they move? You're going to have to change first of all, you're going to have to know that the two of them are married and that they have the same address. So you have to change both of them, and you have to change your address here, and you have to change it here, and you have to change it here, and you have to change it here. What if you forget? You miss one of them. You don't change this address. You leave this with their old address. What problems could that cause? What if the price of a tablet PC goes up? But you may want to keep the original purchase price. Let's suppose the price of the smartphone goes up to 500, but you need to keep the 400 because that was the actual sales price. Well, you're going to need to store both of them somehow. So it looks organized. It's not structured in a very efficient way. You have a lot of redundancy. You have the same information being stored a lot of times. If there's even a small change, someone gets married, maybe this address was entered incorrectly with 3541B. Now you got to change that one potentially hundreds of times. It can be just a mess. So when we do database design, one of the things we look at is a process that we call normalization. And I'm not going to get into all the technical details of that. In layman's terms, what that means is we're going to split up the tables to reduce redundancy. I mean, that's a vast oversimplification, but for our purposes, it'll do. So what we're going to do, what I did is I took a row from the original spreadsheet and just kind of color coded it. So the purple items are things that will change per order. And the red, this red area, well, these are things that are specific only to the customer. So if this customer has several orders, this is the information that's going to be repeated. So what we do is we take Cindy Brown's information, and we still have Cindy Brown and Charles Brown separated. That we may just have to keep those two separate entries. But you see what we've done here is we've put in another field, another column called customer ID. This Cindy has a customer ID of 2, and now we have a separate table for the orders. So notice I can take the information that's just specific to that order and put it in a different table. So the customer ID only happens once in the customer table, but it can be repeated several times here, one for every order that customer placed. So I don't need to repeat the address and zip code and all that, email, phone number. I don't need to repeat all that stuff because this 2 over here serves as a connector to the 2 over here. We have a terminology for this. This is what we would call a primary key because it uniquely identifies a customer. And the 2 over here is what we call a foreign key because it joins these 2 tables together. The order date is still the same for these 3. There's 3 lines because there were 3 different items that he ordered, 3 different products. And we will take care of that. So that's still a measure of redundancy because even within an order, there's repeated information. Customer number is repeated, the order date is repeated, and the ship method is repeated. So we can go a little further. So we can have a table for customers, We can have a table for orders. Then we could break the orders down into order lines. And not only that, we can put the products in its own table. Small tablet is 50, small tablet is 50. So the small tablet is in here several times. We don't need to store its information multiple times. This process of normalization allows us to split the tables into a more efficient process. So now, if the price of the phone goes up, I only need to change it in one place. If Bernadette Friend gets married and changes her name to Smith, I only have to change it in one place. I don't have to go hunting through all these records. Referential integrity. This is a screenshot from Access on how you could do this. So you want to make sure that if you put a customer ID in the orders table, that customer does in fact exist. Otherwise, when you try to connect it back to an address, you'll get null information. You want to make sure that that there's actually a customer to tie it back to. Otherwise, this link gets broken. And one of the nice things about that, again, this is a screenshot taken from Access. What we see here is the order lines table nested within the orders table, nested within the customers table. So this actually, you can expand all of this out and show basically it's a table within a table within a table. This is the advantage that Access gives you. This is what you can't do, at least not very easily, within Excel. Access gives you the ability to create relationships among these tables. And it allows us to kind of nest or cascade these tables so that one is almost a subset of the next. And so the advantages of normalization, again, you have less repetition of data. You won't have orphan records, and because what happens because that's the other end of it. What happens if, for some reason, Ryan John is, let's suppose, he gets removed from our customer list? Well, he's still got orders in there. This now becomes an orphaned record. We have an order that refers to a non-existent customer ID. So that's another thing that the referential integrity gives you. It avoids orphaned records. It cuts back on storage, especially if you have a very, very large data table. Reduces data entry errors. A lot of that is at the application level itself. So here we see examples of a relational database. Now, this is not the database itself, but these are forms built using Microsoft Access. So in conclusion, data is everywhere. We showed the cost of not having organized data, the cost of data entry, and we've showed a few solutions. And I actually want to finish one more thing. This is another example of an Access database where I've taken the information we saw earlier, and this is the normalized version of the data that we had before. Now, I'm not going to go into the details of what a query is, but this basically, what this does, it basically takes the pieces and puts them back together, and reassembles the table, the original spreadsheet in effect, or denormalizes the data. But making this into an application is surprisingly simple. So what I've done is I've created a quick query here and just connecting the customers and orders table. And I'm just going to make a very quick form for this. I'm going to use the form wizard. Using query 1, I want, let's just put everything in there. I only picked a few fields from each. And now with just a few mouse clicks, we have a form. Not a very elegant one, but you can scroll to the customers and you can see the order IDs and the order date, and all this is organized. If gets married, changes her name to Cooper Smith, and now I only change it in that one place. And now when I go to all information and refresh, see, it's changed everywhere. I don't have to go line by line and changing it. So that's a very important. Now, again, this form here is very crude. I created it in about 30 seconds using a form wizard. So this is not would not be a final product. So there would be a lot of customization and a lot of programming and code that goes behind this as well. But the point is, this is what relational databases are. This is what Access is, a way to relate these tables. If I go to relationships, this shows us how all the tables are related in the relational database, and how we can use forms to better access our data. And again, this is just this is just the very tip of the iceberg here to show you what relational data is and why your business needs it, because this is customers and orders, but everything is data. Again, customer records, employee records, sales leads, inventory, you name it, you've got data, and it needs to be organized in a way that makes it efficient, easy, and easy for your staff, easy for your customers, easier for everyone. Just to show one other example, this comes from an address book database, and we get to the whole issue of how do we avoid data entry errors? Well, we design the form, and again, this is a lot more sophisticated than we would get with with the wizards. But I can make sure, for example, I can put the most common cities in a drop-down to make sure that you actually enter a city. Don't spell it. I mean, can a person go in there and misspell Spokane? Yeah, they can. But it reduces the chance of that. Whatever you put in the state field must actually be a state. Zip code. Well, the zip code, first of all, you can't really see this, but it will not allow me to type letters. I can only type in up to 9 digits with that zip code separator. Must choose a country, and again, if there's another country in there, you could still type that in. Can't do it with the state. If I type a non-existent state, or if I type in IDA for Idaho, won't let me do it. So this is how you can protect against things like this. Make sure what you're typing is in the list. Let's change it back to Washington. If we were entering an email address has to be in a particular format. The phone has to be 3-digit area code, and you see it also has input masks. So it will not let you type in bad information. The phone number has to be a phone number, a state has to be a state, country has to be a country. Again, could you go into country and type Spokane? Yes, you could. But you put the most commonly used cities here, and then you figure sometimes you'll need to enter something else. But at least if it's a common city, you know it'll be spelled correctly, especially for something like Coeur d'Alene, Idaho. You've probably seen that spelled about 10 different ways. So that's it. That's it for the presentation. Again, I promised you it wouldn't be a salesy presentation. But if you have questions, all of my information is up here, my LinkedIn address, my email. We can set up a free 30-minute consultation. Just go to this address and we can get everything set up that you need. All right. Again, thanks for watching.